Yeah, so I'm Ali Habibi. I'm a structural engineer at Northrop, one of the principal, the shareholder of Northrop, and also now I'm operational leads for our nationally for a structural division. Uh, but at the same time, I love timber, so that's why I'm one of the timber engineers at Northrop and leading a team that love to work on sustainable material and sustainable buildings.
Yeah. And you're one of the many people, well, not too many, but you do a good presentations, and then you do one good presentation, and all of a sudden you're on the speaker circuit doing all the conferences, and eventually you you come on the podcast. So that's usually
Yeah,
how it works.
I've been lucky enough, to be honest, to be tapped on the shoulder with someone like you to attend this.
No,
But yeah, I enjoy sharing the knowledge and also learning from others because, in my opinion, that's our responsibility to share our knowledge. If you want to gain from others, I hope I try to do it. Hopefully, people will find it useful for them.
yeah, 100%. So the major overarching topic we're speaking about today is the Mass Timber Innovation Hub at University of Newcastle. Can you describe just a little bit about this project and also leading into some of the drivers and maybe why timber was chosen for this project?
Yeah, so this project was one of the interesting one because it is the first timber office and teaching space for University of Newcastle. University of Newcastle has a big sustainability aspiration as well to provide an elegant exposed structure. That's part of the brief. The university also wanted to have the project included a desire to create world-class sustainable facility that demonstrates a commitment to social, environmental, and economical leadership. So, to be honest, that was a big thing and help to put timber in place. This happened before we get on the job. It is like a, let's say, 4-story timber office teaching space, but similar to offices, columns and beams, glue lamp column and beams, and CLT slabs with beautiful facade. It was innovative facade, and also there are other sustainability initiatives that put in place from other disciplines as well.
Yeah. What were some of the major challenges of this project?
So, in my opinion, this project is not different to any other timber projects. One of the big challenge is services coordination. Normally, in a traditional way for any type of like concrete or steel buildings, even with timber, the services consultant start the job. They finish at 70% documentation, tender documentation. Builder get involved as a DNC things, and then they will select the services subcontractor late on the job. Unlike concrete buildings that you could easily say, oh, okay, so all the services go under, I don't need to do anything with that. For timber, services coordination is very important. Any penetrations into the beams or slabs need a certain detailing from a structural point of view. So that coordination was a key challenge. But I always say any challenge comes with opportunities. So we proactively come on to BIM 360 to do clash detection with the services team. To be honest, a big credit to Hansen Janken, who was the builder, that they lead and manage that clash detection, and they did a great job. But that was one of the big challenges. The other thing is, like in timber supply, we have different suppliers. In Australia, Xlam, we have pretty good company. Also, overseas, we have a number of different suppliers, and unfortunately, not all of them, they have the same sizes. Like panelization is a big thing, for example, for this job, because instead of like normally 2.2 meter width CLT panels, we had to go to 1.25, for example, CLT panel. Why it is a challenge? Because from earthquake point of view, you need to have a kind of monolithic slabs to bring the loads back to the lateral stability system. So designing those panelizations and come with a good ideas, not adding other lateral stability, but also we achieved to delete 2 of those big bracing, which was a big saving for the university as well as the builder. The other thing is program and fabrications. Like, is unlike concrete building that you design it and the next day they go and they select number of different crews come to site, not the next day, but like in a much shorter period of time. You need to allow for, okay, so how much shop drawings will take, then fabrication, then delivery, especially with this job come from Austria, and other challenges. So you need to calculate backward and design in a way to be able to achieve those deadlines. So that's definitely is another challenge, which we successfully with Hans and Janken and EGAE as an architect, and also the whole team, we achieved to meet the deadline of the project.
I might drill down on one of the points you raised about different suppliers with different grades. Like for a concrete building, you can just specify concrete strength and forget about it. But for this, specifying grades, it sort of may or may not limit some of the supply chain, but at the same time, you're trying to maintain the performance. I mean, how do you go about what grades to specify, considering the flow-on effects from choices at the beginning of a project?
Yeah, so that's a very good question. What we normally do for any design, we put 2 options in front of the client, like that it's a mean value for, like, let's say Australian supply and overseas supply. And we say, like, this is 2 options. This is pros and cons. Like here, you could have a wider panel, longer panel from XLAM, but like elastic modulus is lower than what that. You might pay a bit for thickness, but you gain this and that. And then they will go and check the price. We don't go based on one, because if you go based on one, then you need to do a lot of like coordination later on, especially for office building when you have a bigger span. For residential, you don't have that problem that much because the span is small. It doesn't matter what elastic modulus you use for deflection. Sorry for any like a technical word that I'm using. I'm not sure that everyone listening to this is a is engineer. I try to avoid any jargon in this, but yeah,
that's so good. I'm also interested, Ali, about think back to the first time you did a post and beam building as an engineer. I'd imagine it might have taken a little while compared to where you do it now. Is it much quicker with the experience? Like say for other engineers who haven't done it, the first one might be intimidating, but once you do your first, is it much more straightforward, or is there still lots of challenges that just inevitably come up all the time?
Definitely, like any other project, the experience helps you a lot. Thinking a bit upfront about the problem and put it on the table is important. The good part of it that you could support other teams that then they haven't done timber building. So for this project, I won't mention name, but there were certain consultants that they never done a timber buildings, and we were trying to be helpful and go and say like, oh, you think that you could do it? You need to think about these things, and lesson learned. You learn from the previous projects, help you a lot, especially if you are a good listener and listen to not only to your client, but also to other trades, to installers and manufacturer, and understand their limitations, and even building services that I mentioned, like you get to know, like, okay, this type of building, what sort of like duct you need to think about in advance before even they come, where you roughly think the services will go. Definitely that helped a lot and make the product much more efficient. Yeah,
it makes total sense. What do you, so from an engineer's perspective, what do you see as the role changing, and what about more specifically the modeling and fabrication process? From my previous experience, sometimes there can be a scope gap there and repetition of modeling and all that. So how do you see as the best way of who handles that and the delivery of a model through to fabrication?
I think this is definitely identified as a gap there. Like people that they know about the term LOD 200, LOD 300, LOD 400, this level of like detailing and design in, let's say, Revit and drawings. Unfortunately, people that new in timber, they think they could do the same level of detailing that they do for concrete, you know. So we draw beams and columns, we get the details later on. This is not how timber works. So you need to think about how the connection works together upfront. You need to think about how the fire work in this scenario and design it. That's why you need to spend more upfront work compared to traditional way doing it. Then you get to the certain point, we normally, for any jobs that we do, we actually, to be honest, from commercial point of view, we put 2 fee, 2 fee proposal in. We say, look, we will, this is our fee for do LOD 300, which we draw beams and columns, but the connection will be in 2D format. If you want LOD 400, I think we are the only one that we offer at the moment in as a consultant. Obviously, manufacturer, they do this to say, like, we can do more in 3D, understand where the screw is going. Is it going to have clash with you? Because in 2D, you cannot check that one. Basically, our model and drawing will be ready to immediately go for shop drawing. We've done one project here. We've done LOD 400, Law School for Macquarie Uni, which we were engaged to do that actually. We were in the fall. And that was a really good lesson learned, understanding you need to understand a lot from the supplier limitation, and supplier to supplier might change. So this is definitely a gap, but if a consultant educate themselves in this space, you could offer some savings for the clients in terms of time. And also, especially this time that many of the suppliers are busy with lots of like demand out there, you could help them as well to offer that. But that's definitely the biggest difference. Like in concrete, most of the time they ask us to use LOD 300. We will resolve the detailing later on. Here, that's a gap, you know. And even if you don't do it, then you spend a lot of coordination time between you and supplier to answering their questions. Yeah, that's what we just recently started almost a year ago. We are offering that to our clients as well.
Yeah, fantastic. I can imagine that's a really valuable offering. And, you know, for people new to this space might, you know, well, I guess people with experience realize the value in what that is coming from an engineer handling that responsibility. I believe this project also had exposed timber. Can you just touch on the fire design and compliance for the project?
Yeah, I think I will start with compliance. The first things that I found, like some people will get nervous about, oh, how it's going to work from compliance point of view. Fortunately, our BCA code and NCC allow us to do a performance solution. And this performance solution is nothing new. We still use in some areas for concrete buildings. This is no difference. Like it would be very hard for buildings like this, office building with bigger span, frame building to go deemed to satisfy. It's almost impossible. Unlike some of those low-rise resi that you might do that. For performance solution, you are allowed to do different things. And for these type of buildings, we use Eurocode more often than Australian code. Hopefully Australian code get more input into that and becomes competitive with Eurocode. But that's not the only reason. The other reason, if you use spruce, for example, materials being tested in Europe in that Eurocode, you'd better to use that. Here, for example, we have one job, which is a really good job, advanced manufacturing research facilities, that we use Australian supply and we're using Australian code, but still you need to go performance solution because it's not that. That's the first things that I think everyone need to know, but it's not something new. As I said, you use that for steel and concrete before in certain area. The other things from fire point of view, unlike concrete building, you said, okay, fire engineer, it's to you. You tell me what to, like, you don't even talk to them that often. For timber, we write the whole chapter for them. We always put the structural fire, giving them to our fire engineers friends, and we go and talk to them, understand their limitation, and we add that. For this building, we wrote the whole chapter for fire engineering, and we've done it for any other projects as well. And that's helped us also to understand how it works from fire engineering point of view. That's a key. As a structural engineer, you cannot just leave it to fire engineer to do that. because then you will be limited to what kind of connection you use, or how your building works during fire. You need to learn from them how it works, but also put your input into that fire engineering report.
So you do a bit of performance solutions, so design based on char rates. The reason I ask a question is simple as that, because I see, there's maybe a belief out there that every single tiny thing needs to be fire tested and the FRL determined by fire test, and there's no room for the engineers doing char rate design and working out the FRL that way. I mean, what's your perspective on that?
100%. I agree with you. I always say, like, why you are not asking this question for concrete building? Have you ever put a big concrete building in fire and test how that specific element works? In my opinion, there's been enough work especially for glue lamp, to give you a specific fire rating. What we normally do, we look at the overall picture, which is normally fire engineer does that, but we work collaboratively with them. So look, if this part of the timber will burn out, what will happen to a structure? Is it still stands and let the people to go out of the building before anyone get killed or had a serious damage? Some people will ask us, like, oh, what will happen to this building after 90 minutes? Can you use it? I said, look, if you have 90 minutes fire in a concrete building, can you use it? How much of it you can use it? If the whole thing is in yes, concrete will spoil off, all your post tension or steel will be exposed. Yes, you possibly could do, but you need to do a lot of rehabilitation. But if it is in a small little area, in my opinion, timber is much easier, because you could take one of the element out and replace it with new. For post tension slab, it is very hard to do that. I'm saying, like, it is the same challenge in my opinion. It's just educating people that this is not something that we take risk. There's been a lot of R&D, research and development projects. I've been engaged with Griffith University, doing some work and testing with them with fire, and few others research center to go. But we also every day, not every day, it's a lie, every week or month I read a new journal paper or new things about the fire compliance of timber, because you need to educate yourself.
Yeah, absolutely. That's such a refreshing perspective. What are some of the challenges on this project, and more generally, that you think, isn't that lessons learned category, or things that are still a challenge right now that need to be still worked upon?
Yes, I think the first thing for me is lesson learned is listen. If you want to get better at timber building, listen to installer, listen to builder, listen to manufacturer. Sometimes some of their feedback might not be very pleasant for you, but you'll use it for the next job. And try to work collaboratively. You cannot say, oh, this is another trade, I don't care about that. You need to see, okay, I designed this, it works on paper. Can an installer go and put his hands down there to put this screw in or this bolt in? If not, how could I change the design in a way? Because unlike concrete buildings, there are not many rooms for installer to put the timber, because everything comes with CNC machines in a fraction of millimeters, perfect, connecting together. So you need to think it of like a, let's say, IKEA. how mad it will be that you buy something from IKEA, but you couldn't fix the connection together. That's one thing. And also from builder point of view, in terms of timing, understanding of cost implications for any changes you go through it, and when to put things on. In my opinion, that's a big lesson learned. And the other things is what we did and we learned, sending people into Europe to manufacturing facility for a couple of weeks, and that's and go and see other facilities to learn all those hands-on experience that you cannot learn it in the office and reading books. That's, in my opinion, that's been very helpful for us.
Yeah, Makes a lot of sense. Well, it's been phenomenal speaking to you, Ali. One of my final questions for you is, how do you see the future of mass timber construction evolving, and where is it going to go in the next 5-10 years and beyond?
Yeah. Exciting news for Australia is Brisbane Olympic 2032 is the first Olympic that's the aspiration is to have negative carbon footprint. That means a lot of good news for timber industry and sustainability in general for Australia. So I think we could make a lot of help in this space to bringing some of those timber projects in line. We've already done one stadium, Eric Tweedle Stadium, that we won all possible timber award last year, but that was a smaller scale. We can do bigger in that sport facilities. But as I said, there is lots of other buildings around that you could bring timber as one of those good factors to go negative carbon footprint. But in my opinion, one of the areas that I'm really keen to do, and we doing with some other builders and developer, is hybrid system. In my opinion, we need to know there is limitation for any material. Timber has certain limitation. Timber is not the prescriptive solution for everything. So we need to understand the limitation and try to come up with number of like hybrid systems, steel and timber, concrete and timber. We're doing one job at the moment. We've finished one job and we're doing another jobs that it is hybrid system. Get the best out of each material is the future, in my opinion, and learn about like, okay, so where timber works the best, where other material works the best, not go head to head with other trades. Let's work collaboratively. Each can get their share of the market and also get the future of the world, like think about the future of our world for our children.
That's so good. What a good note to end on. It's been great speaking to you, Ali. If people want to find out more about yourself or Northrop or anything you want the listeners to go and check out, where should they go?
Like we have a good website, but it's LinkedIn is one of the things that we normally try to be active as a company. Go through it. But if anyone wants to talk to me, I'm happy to put my email address and mobile phone out there.
Oh, that's
yes.
a mobile phone. That's unusual. That's that's a good one though. It's generous.
Yeah, normally it's good to help others because you will get some help later on. So I'm happy to help anyone normally has question. It's because it's for a good cause, in my opinion.
Yeah.
We need, me and you and many others that active in timber space, we need to be advocate for this beautiful material out there.